Good morning and happy Tuesday. So today I want to finish up the determinants but study the 3x3 matrices and give you a shortcut for 3x3 and even larger matrices down the road. So the symbol for the determinants, remember, looks like parallel lines, 3 rows, 3 columns. The rule of thought to find the determinants, you take the first row and you use the A value, the B value, C value as the numbers out in front that you multiply. This is always going to be a positive. We always end up negating whatever number that is, B, and we keep the positive C. And what we end up doing, we take this number A and multiply it to the determinant of the smaller matrix here. And then we do the same thing with the B, negative B of course, and multiply negative B with the determinant made up of these two as well as those two elements. And then we take C and multiply it by this lower left-hand corner matrix. Back in the day when this was covered on the IB exam, this formula actually was given. So basically what it means, you're taking A times the determinant minus B times the determinant of the middle matrix and C. Now, you're welcome to use this as your notes, but I will show you a shortcut that I learned in college, which makes it so much easier for larger matrices. So again, for number 1, I want to find the determinant of this 3x3 matrix. Take 12 and write out in front and create the smaller 2x2 matrix, this block here, minus the 4 times the matrix created by these two and those last two. Now here, be careful, that's a -1. So it's still plus, but I'm going to put parentheses around the -1 so I don't forget to multiply that. And then the matrix created by this small block here. So here I'll get 12, and the determinant here will be 3 minus 16, which is -13, minus 4 times -2 minus 10, -12, minus 1, that's what plus a -1 is. So I'd find the determinant here, so -16 minus 15, -31. And the rest of the work is just simple calculation. So I gotta take 12 times -13, add to that, or actually subtract 4 times -12, and then minus 1 times -31, I end up getting -77. And that's your determinant. So again, the purpose of the determinant is down the road to help us find the inverses of these matrices. Next example, 5 times this 2x2 matrix, so it'll be 5 times, let's see, 2 minus 1 is 1. Minus the negative, if you want to change the sign now, you're welcome to do so. So the determinant of this smaller 2x2, 4, 0, 1, 1, that will be 4 minus 0, which is 4, plus 4, and the determinant of this smaller 2x2 matrix will be 4 minus 0, which is 4. So we'll get here 5 plus 36 plus 16. So 5 plus 36 plus 16, and my calculator off to the side here equals 57. That's your determinant there. Now the shortcut. Okay. What you do with the shortcut, you rewrite the first two columns. So 1, 4, 0, -2, 3, 6. And what you end up doing, you find the diagonals going from left to right's product. Okay, so I'm going to take 1, 3, 0, -2, 5, 0, and it looks like here, -3, 4, 6. I'm going to find those products and add them together. Well, 1 times 3 times 0 is 0. -2 times 5 times 0 is 0. And see, -3 times 4 is -12 plus times 6 is -72. So that's -72. And then I go back the other way. So I have here -2, 4, 0, which is 0. 1, 5 times 6, that's 30. And then I have here -3 times, ooh, another 0. So we end up doing, we take -72 And we're going to subtract the other way from right to left diagonal products, 30, and we get negative 102. I don't know who created this shortcut. It's a shortcut that's taught in more college math books, but I thought I'd share it with you since I'm giving you a peek into future math in college. So try both methods. You know, I'll send these notes along so you can keep the formula. I don't know in college if they give you this formula or not. But we haven't taught this since 2012. I could be mistaken. It's been good 8-10 years since I had to teach this in IB math. If you have any questions, let me know. Thanks.